This is Mrs. Waynard's Math Class, Chapters 6, 7, and 8, Packet B, Lesson 1, Part 2. This is the lazy matrix for greatest common factor, otherwise known as G.C.F. Today's learning target: I can use divisibility rules to find the G.C.F. of two or more numbers using some shortcuts. For this lesson, it's going to show you the shortcuts. You do not have to use the shortcuts. You would only want to use them if you really understand them, and they do make it quicker and easier for you to get the correct answer. If not, then I would definitely recommend using the original way we taught you, because the most important thing in math is to find the correct answer. So example number 1 from the original lesson said find the GCF of 24 and 40. For my shortcut or my lazy man trick, I would go ahead and take the first number. Usually I would take the smaller number, and I would find all of the factors of my smaller number, all of the partners, exactly the way I always do it. Here comes the shortcut. Rather than finding all of the factors for the second number, I would start at the greatest number. After all, we are looking for the greatest common factor, and the greatest factor of 24 is 24, and I would say, is that a factor of 40, or does it divide evenly into 40 with no remainder? If you're not sure, you can do a division problem, or if you're still not sure, go back to the original way, because that will always work. But here's what goes through my head. I say, well, 24 is less than 40. And 24 and 24 is going to be more than 40, right? Because 20 and 20 is 40. That would be 48. So 24 is not going to divide evenly into 40. That doesn't work. So let me move down the line. What about 12? Go through my 12 times tables. 12, 24, 36, 48. 12 doesn't work either. Cross that out. Move down the line. 8. 8, 16, 24, 32, 40. Oh, 8 does work. So if 8 divides evenly into 40, I now know that my GCF, my greatest common factor, is indeed 8. Let's take a look at example number 2. Example number 2 from the original lesson said find the GCF of 22 and 55. So again, I'm going to take my smaller number, and I'm going to find all of the factors of my smaller number. Now, I will look at my next number. In this case was the 55. And since I'm looking for the greatest common factor, as always, I start with the greatest number and see if that's a factor of the other number or if it divides evenly into it with no remainder. Does 22 go into 55? Again, if I'm not sure, I could do a division problem, but I say 22, then it would come 44, then it would be 66. No, 22 does not go into 55. That doesn't work. Move down the line. Next number I look at is 11. When I go through my 11 times tables, do I get 55? Yes, I do. 11, 22, 33, 44, 55. So 11 does divide evenly into 55. Therefore, 11 is my GCF of the two numbers. Let's go on and take a look at number 3. For number 3, we had the word problem. On a rainy day, 8 students wanted to play board games, 36 students wanted to use computers, and 52 students wanted to play in the gym. The lunch monitors need to divide these students into smaller groups. What's the greatest number of students that can be in each group while all groups are the same size? So we had said, when we went back and looked at this problem, that we need to find the GCF of these numbers: 8, 36, and 52. Let's do this in the shortcut. So I move to paper so I have room, and again I'm finding the GCF of 8, 36, and 52. I take my smaller number, which is my 8, and let's find the factors. We always start with 1. Its partner is itself 8. Does 2 work? Well, it's an even number, so it has to. 2 times 4 equals 8. Does 3 work? No. Does 4 work? 4 is already there. So those are my factors. 1, 2, and 4 are the factors of 8. My next number is 36. So I'll write that down just to focus on it. And in this problem I have a third number, which is 52. So I wrote that down as well. This will be a little trickier because there are 3 numbers. So again, you could always write all the factors of 8, all the factors of 36, and then do the trick that I just showed you. But I'm going to show you how to do the full-fledged trick. So I have my factors of 8. I'm looking for the greatest common factor, so I'm going to start with the greatest number. And I'm going to focus in on my first number, which is the 36. When I go through my 8 times tables, do I say 36? 8, 16, 24, 32, 40? No, I don't. So 8 cannot be the answer. Now I'll move on to the 4. When I go through my 4 times tables, do I say 36? 4, 8, 12, 16, 20, 24, 28, 32, 36. Yes, I do. So 4 may work for the 36. But now I'm going to need to see if 4 goes into 52. I'm really not so sure because the most I know up to is 48. So I'll do a little bit of a division problem. And I'll say my 52 divided by the number that I'm checking out to see if it works, which is 4. 4 goes into 5 one time. That's 4. I subtract to get 1. Bring down the 2. 4 goes into 12 3 times. 3 times 4 is 12. And I have a remainder of 0, which means it does divide evenly. Therefore, that means that 4 is my GCF because it's a factor of 8, it's a factor of 36, and it's a factor of 2. And of course, it's the greatest factor. Therefore, it's my GCF. And finally, let's look at the last example from the original video. It says, what's the GCF of 7, 13, and 15? Again, I have 3 numbers. I'm going to take my first number, which is my 7, write it down, and I'll find the factors. 1 and 7. Does 2 work? No, it's not an even number. It can't. Does 3 work? Well, when I add that up, I get 7, and 3 doesn't go into 7, so 3 doesn't work. Does 4 work? No, 4, 8. Does 5 work? Doesn't end in a 0 or 5. 6. There's no 2 or 3, so there can't be a 6. 7, up. 7's there already. So my factors of 7 are 1 and 7. Oh, remember this? When a number's only factors are 1 and itself, it is called a prime number. 7 is a prime number because the only factors are 1 and 7. Okay, well, we know 7 is a prime number, but we still do need to find what the GCF of 7, 13, and 15 is. So again, here we go with our easier trick. So I found the factors of 7. I'll next need to see if that goes into 13 and 15, since those are the 3 numbers that they gave me. Again, I'm looking for the greatest common factor, so I'm going to find the greatest factor of 7, which is 7. When I go through my 7 times tables, do I get to 13? 7, 14, no I don't. So 7 cannot be the GCF because it's not a common factor of 13. What's the next factor I have to try? Well, there's only one left, and it's a 1. 1 is a factor of everything. So does 1 go into 13? Of course it does. Does 1 go into 15? Of course it does. So the GCF of 1, 13, and 15 is going to be 1. And that's it. That's the little bit of the lazy man trick to help you out with finding the GCF of numbers. Again, you do not need to use this trick. You may want to use it when it's just smaller numbers because it's easier to see, and go through all of the factors when it's larger numbers and when it's, past the multiples that you know for sure. But you can try it. Again, here's the thing to always remember, as we say all the time in math, use whatever tricks that you can use that help you to get the correct answer most of the time. If this trick isn't working for you, you shouldn't use it. Good luck with the lesson.